Hello everyone, I'm Brian. Welcome to my channel. This is first video and I'm really happy to see you here. Today I'm going to show you one interesting chemical phenomenon. This is co-equilibrium system and I will show you the effects of temperature, how is this and how it's happened in a real life. Now let's get started. As you know, chemical reactions happen everywhere. Some reactions go to combustion, such as burning or sodium reacts with water, but other reactions do not go to combustion, such as the formation of limestone or the bicarbonate buffer system in your blood. The thing is that when the forward reaction proceeds and the products are formed, the reverse reaction proceeds as well until the equilibrium state is achieved. At that point, the rate of forward reaction equal with the rate of reverse reaction and keep the concentrations of any substance unchanged until all the disturbances happen, such as change in temperature, change in pressure, or change in concentration. But what exactly the principle of this phenomenon? A French scientist allegedly has found the principle. The principle is if an equilibrium system is straight, the system will experience a shift in response to the stress that will re-establish the equilibrium. How about the effects of temperature? For the exothermic processes, heat is viewed as the product of reaction, so the opposite temperature dependencies is observed. If the heat is hottest, the reverse reaction will speed up, which reduce the concentrations of all product. For the endothermic processes, heat is viewed as a reactant. If the temperature of the system is raised, the forward reaction will speed up, and so the equilibrium will shift to the right. Now take the experiment to see what does it look like. In this experiment, we will take the experience of the mix of gas, nitrogen dioxide and dinitrogen dioxide. We need some materials such as a copper chip, a nitric acid crucible tongue, a large test tube with the stopper, and the beaker half filled with hot water and cold water. Before we making the experiment, I would like to make some safety point because acid nitrous is corrosive and nitrogen dioxide is toxic. We only use the substances in the firm hold. The conductor must wear the glove and safety glasses before making the experiment. To start, a piece of copper will add this to the tubes. In the firm hose, 1 milliliter of concentrated of acid nitrous will added to the tubes, which rapidly will see firmly. The conductor return to workstation and allow few minutes for the copper react. After that, the tube will place alternately in the hot and the cold water. So let's see what's happened. As the result of the first step, copper will react with acid nitrous to form nitrogen dioxide, and nitrogen dioxide form dinitrogen dioxide. Nitrogen dioxide is brown gold, and dinitrogen dioxide is colorless gold. So as the result, the mixed gas released in the test tube were yellow to brown. When we push the system at the hot water, the temperature will added and considered to add more product. As the result, the reverse reaction will speed up and increase the concentrations of nitrogen dioxide. So finally, the color slightly turned darker. If you put the system at the cold water, the temperature will reduce and considered to reduce product. As the result, the forward reaction will speed up and increase the concentrations of dinitrogen dioxide. So finally, the color slightly turned faded. Now let's see what happened in the real life. Naturally, a principle is used in many industrial processes. One of that is the hyper process, which is the process of manufacture the ammonia from hydrogen and nitrogen. The principle is used to maximize the production of ammonia while keep operating in production cost in mind. The principle tells us that increase the pressure will favor the side with fewer mole. In this case, it's expensive to operate and build the system that can withstand such a high pressure like that. In fact, a pressure of 200 atm is used. It would make sense to conduct the system at a low temperature. In fact, the temperature of 400 to 450 Celsius is used. On in all, the use of this process from 10 to 20%, and we have to use the effect of temperature for maximize the production of ammonia. That's all I can share you today. Thank you for watching this video.